In this lesson, we'll learn how to place electrical components and wires on our robot. Learning good wiring techniques can be extremely beneficial in learning to manage space and will give us a better chance of detecting physical interference before it happens. We'll also learn about the flatten route feature in SOLIDWORKS, which allows us to calculate the total length of wires and how it benefits our robotics team. Here's our sample robot assembly with the Victor 883 motor controller on the base plate. We can get the Victor 883 motor controller from the 3D Content Central database. We'll be learning how to place wires between the motor and the controller. Before we can begin wiring, we need to enable the SOLIDWORKS routing feature. The routing feature allows us to create a special type of subassembly that allows us to place electrical wires, tubes, or pipes between components. In order to enable SOLIDWORKS routing, go to Tools, then Add-ins, and then we select the SOLIDWORKS routing feature. In order to have a better perspective on our working space, we'll use the Isolate feature to single out the components of our interest. In our case, let's select our base plate, motor controller, motor, and C-frame. Now right-click on the components and select Isolate. To place a wire on the motor controller, we need to determine the path which the wires should follow. The ideal routing path we want to have is one without obstacles to interfere with our wires. Therefore, we must take into consideration all the parts or assemblies that could potentially block our path. Now we need to place fasteners. Fasteners are a feature to hold our wires in place. SOLIDWORKS provides us with pre-made generic electrical components that we can use. We can find them under Routing in the Design library on our right-hand side. Now let's go ahead and expand Routing. In our lesson, we'll be using the electrical folder. So let's expand it and find two subfolders called Harnessing and Ribbon Cable. The clips and fasteners that we can use can be found in these folders. We'll use the wire tie clips. Locate them in the routing library and we can add them to our assembly by simply dragging them into our workspace. Let's go ahead and place one wire tie clip on the side face of the base plate. SOLIDWORKS will prompt us to select a configuration. Let's select 8 mm. Now place 3 more clips where needed. We can use the Rotate and Move component tool to orient the clip in the right direction. Now we need to add the connectors. We'll use the blue ring connector. First, let's drag it over to a connection on the motor. Then, with smart mates in place, the connector will snap onto the appropriate feature. We repeat the process for the other connector. We're now going to add both the negative and positive connectors to the Victor controller. Now we're ready to start our routing process. Let's start from the motor. The point of interest is the wire tie. We simply click on the connection point on the wire tie. Now we need 2 wires for the positive and the negative to branch off from the wire tie. We can continue routing the wire through the clips by selecting the connection points. When we get to the motor controller, we follow the same steps to split the wire after the wire clip that we used to connect the wires to the motor. Now we can finish and exit auto route. And if we need to, we can use the Move and Rotate component tool to move our wire ties and change the wire path. If we look at the Feature Manager, we see that the wiring route including the clips and the connectors has been saved as a separate subassembly within our existing robot main assembly. The biggest benefit of routing our robot using SOLIDWORKS is that we can determine the length of wires we need for our robot. We can save valuable time and money by knowing how much wire we'll need before we purchase it. Thus, routing the wires correctly in SOLIDWORKS is a very important step to building a successful robotics team. To calculate the length of the wires, we're going to use the Flatten Route tool from the Electrical tab. Select all the options, Electrical BOM, Cut List, Connect Table. We can observe that a flattened drawing is created. Then, SOLIDWORKS calculates the length of the wire you need for each branch of the wire. In this lesson, we learned how to use SOLIDWORKS routing to create an electrical route assembly for our robot. We also learned how to use the Flatten Route tool to determine the length of wires we'll need.